This is 5.5, Graphing from Data, and I found this cartoon and I just loved it because it reminds me of solving those identities. You get down to the bottom, you can't make it work, and then you realize that it was the first step, that you made your mistake. So anyway, I thought you'd like that. So this lesson is talking about two things. One, mostly graphing sinusoidal equations, but it's also talking about doing regressions. And for both of these, you'll need a calculator, although some of it we're going to do by hand, and then we'll do some of it with a calculator. You can see here on this slide that it has the question, what makes a function sinusoidal? And remember, sinusoidal just means that it looks like a sine curve. So cosine is also sinusoidal. Tangent is not. So this one is non-sinusoidal, although it kind of looks like it's cyclical. It does repeat its pattern. And then this one also is not sinusoidal because it's not a regular, it doesn't have a regular amplitude. But it looks, kind of sinusoidal, very different. So this is an application like you would do if you were looking at any kind of data and writing some kind of data that might actually look sinusoidal. And so the first step on this is that we're going to graph the data points. So you have been given a sheet of paper, and on your sheet of paper you're going to actually graph the points. So stop right now and do the points on the paper that you've been given. And I'm going to stop it here and write them in so you don't have to watch me graph. One thing I am going to say, I graphed one point and then I realized these are by months, and the one along the x-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, those correspond to the months, and this side on the y-axis corresponds to the temperatures. So for instance, in January, the temperature is 46.5. So hopefully you will know what that is, so I'll come back in a second. Okay, so you can see here I've got these graphed, and they're, they're pretty close. It looks like I have August a little higher than July, and it really should be the other way around, but this is pretty close, and you can kind of see that there is a sinusoidal relationship all the way up and all the way down. And then we want to find the domain and range. Well, the domain, of course, is going to be the months. So we're going to be from 1 to 12, and we're going to include 1 and 12. And then the range looks like it's somewhere between 46.5 to what? Yeah, all the way up to July, which is 93.8. And so we've graphed the data points, and now we found the domain and the range. Okay, so what we're going to do is we're going to, by hand, come up with an equation for sine that will incorporate as many of these data points on the curve. So if you'll remember, the equation for the sine, sinusoidal function, is y equals a sine b x plus or minus c plus or minus d. All right, so we're going to be looking for a, b, c, and d so that we can write our own equation. A, remember, computes the amplitude. So the amplitude is going to be halfway between the lowest temperature and the highest temperature. So in other words, we're going to have the highest, I can't spell highest, goodness, try this again, highest minus the lowest temperature and divide that by 2. So if we do that, the highest temperature is in July, 93.8. The lowest temperature is in January, 46.5, and divide that by 2. And we put that in our calculator. We're going to get 23.65, and that will be A. So we're going to keep track of that. Now, the value of B has to do with the period. And the period of sine is 2 pi, right, over B. Now, the period is going to be 12, because there's 12 months, right? So the period are the 12 months, January, so 1 to 12, right? So we have 2 pi over b equals 12. And remember from when we did this before that you could do 2 pi over 12 equals b, and we're in radians, that's the pi, right? And then so b is going to be equal to pi over 6. So now we have b, which my b looks like a 6. There you go, I don't know. Anyway, so now we have b and we have a. Okay, step 3 is to compute the value of c. The phase shift, it says here the phase shift is c divided by b, but the way we had it written, we had the a sine b, and then in parentheses, x plus or minus c, and then plus or minus d. So we don't need to worry about the division part. That's if you had bx plus bc, you know. So we're not going to write it that way. So we still need the phase shift, and phase shift is either right or left. All right, and if you think about what a sine curve looks like, you know, over its 2 pi, it's divided into 4 periods, and it looks roughly like this. So the maximum point, if we were keeping track, the maximum point would occur a fourth of the way through the period. Okay, now our period is 1 through 12, and so a fourth of the way through the period would be the 3rd month. So March, if this were an actual sine curve, the maximum point, the maximum temperature would occur in March. It of course does not. March is 3, right? Instead, the highest temperature occurs in July, which is a phase shift to the right. How many places? So this goes right 1, 2, 3, 4 places. So this is going to be a phase shift to the right 4 places. So C would be equal to 4. And so if I were writing it in the equation, remember that would be the opposite sign, so it would look like this. All right, so far we have A, B, and C. Now we need D. We're going to compute for the value of B, substituting in a data point and solving. Now this is the point where it's going to be, you and I could have different final equations for D, or final values for D, because we could use a different point. There are 12 points we could use. Okay, so for instance, let's do a recap. The amplitude was 23.65. We're using the sine curve, sinusoidal curve. B is going to be pi over 6. And then we have x minus 4. And then we would have, we'll just put plus D there, plus D. Okay, so pick a data point. I think I picked April. April is 4 and 72.1, but obviously you could pick any kind, right? So I'm going to put a 4 in. The reason I picked April was because when I put a 4 in here, 4 minus 4 is what? 0. So that makes that really easy. So I would have 72.1 equals 0 plus D, and then so D would be 72.1. And so that's why I picked it. But you could pick something else. It'll just be more difficult mathematically. All right, so your final equation that we found was an amplitude of 23.65, sine of pi over 6, x minus 4, plus 72.1 degrees. Okay, and there we go. We have that equation. That's what we did by hand. All right. Okay, the next step then is to use the sine reg function on your calculator to find the wave of regression for the data in your table. And so once again, you're going to use 1 for January, etc. And so you're going to go to Stat, and then you're going to go to Edit. And in L1, you're going to put in 1 through 12. And then in L2, you're going to put your temperatures, so 46.5 all the way down to 49.6. So pause it a minute, put all that in your calculator, and then come back. Okay, so I'm grabbing my calculator. All right, so once you get those loaded in, into L1 and L2, making sure that they're even. Then you're going to quit that. So you're going to go to second quit. And you're going to then do stat and over to calc. All right, so when you go to stat and then over to calc, you're going to go down till you find sine regression. And I'm looking on mine, and it looks like it's way down there. It's like C. So you want sine reg, which is C colon. All right? And then when you do that, depending on your operating system, you're going to go ahead and calculate that to actually get an equation. Okay? Now, when I do that, when I do a sine reg, this is what I get. I don't know what you'll get. We'll see. Should be about the same thing, but I get 23.7, and I'm rounding a little bit, sine, and then 0.5x minus 1.85 plus 69.6. And that looks pretty similar, doesn't it? Looks pretty similar. So what I did with April looked very similar to this. The amplitude looks like it's been rounded. This part right here, let me point to it. This part right here is written a little differently, right? This has got, you would have to factor out a 1/2 to be able to get that, but that's pretty close. So you could do this with any data. This uses something fairly simple, but you could use it with any data and to see if it conformed to a sinusoidal curve of some kind. And we're using sine, but you could modify it to use cosine. So there we go. That's this part. Okay, there's a couple of things I want to talk about on this assignment. This has got two curves, two sinusoidal curves. In fact, it looks like cosine. Both of them are cosine, right? Because they both start at 1. One of them is an A. You can see this one here. This A cosine looks like it's got a phase shift. This one is just the cosine. And so you can see right here, cosine. It's got degrees on it, but you can see there's two of them. So what we want to know then, if this is cosine, what did they do A, B, and C to get the this equation for this particular one? Okay, because it looks like it's been moved down. The amplitude has been stretched, it's been moved down, and then it also, look what it finishes. It finishes here in terms of pi. All right. The second B just says find the coordinates of P and Q. And so that's a calculator problem. Putting one in, once you have the equation for this big one here, you can set them in your calculator and see where they intersect. Okay. So what I'm looking for here is A. So let's talk about this a minute. We're looking at A. And I have g of x is equal to A cosine of bx plus c. And actually this is not c, it's d. Does that make sense? It's an up and down. It's been moved up and down, but not left and right. All right, so A is amplitude. So somewhere in the middle here, right, the highest point is 1, the lowest is -3, halfway is going to be 2 up and down, so it's going to have an amplitude of 2. All right, the period is just ends in pi. So to find B, I would say 2 pi divided by B is going to equal pi. Or 2 pi over pi is B, so B is going to be, you're right, 2. All right, so far we have g of x is equal to 2 cosine, and then the amplitude, or the B, let's see, I'm going to amplitude, and then bx, and then we just need c. We need to know how far it's up and down. Well, if this is the midpoint right here, if this is the midway point, then it has been moved down 1. So instead of this being plus, this is actually going to be minus. So I have minus 1. So that's A then. That tells me A. Now, when you have A, then what you want to be able to do then is to find the points of intersection. So be sure that that your calculator is in degrees, because this 2 won't matter as long as it's in degrees. And then put cosine in 1 and this one that we just developed in 2, y2, and then see where the points of intersection are. And so I expect you to have a good start on that by class period. And I will see you in class.